Hey guys, this is Sean with Alexander Tutoring, and today I want to talk about circular motion, which is a very important topic in physics. Okay, so here we have a picture of something going in a circle. It's a bird's eye view, so you can see that we have an object going in a circle like this with velocity v, and we're going to say that its speed is constant. You'll notice that the length of the velocity vector is the same all the way around. That tells you it has the speed is constant. Now, the question is, if the speed is constant, is it possible to be accelerating? Now, you tend to think your first instinct guess might be that no, constant speed means not accelerating. However, the definition of acceleration is not change in speed over change in time, it's change in velocity over change in time, which is an important distinction when it comes to circular motion. The difference, of course, between speed and velocity is speed is a scalar. So, for example, 20 meters per second, and velocity is a vector. So it's a speed represented by the length of the vector as well as a direction. Now, the interesting thing here is you'll notice that even though the length of the vector remains constant as it goes around the circle, the direction is in a constant state of flux. The direction of the velocity v is constantly changing, and therefore, according to the definition of acceleration, which is change in velocity, it is accelerating, which is cool. The next question is, in what direction is it accelerating? Well, it's actually always accelerating towards the center of the circle. That's kind of hard to see. No matter where you are on the trip, it's going towards the center, which again is a little counterintuitive. But if you think about it, let's look at starting here, and then let's say a little bit later, you're over here. Velocity vector is going to look like this. You can see that the vector's been kind of pulled around. In which direction is it being pulled? Right towards the center. So no matter where you are, the acceleration vector is always towards the center of the circle. And that's the really important concept to know when it comes to circular motion. Always accelerating towards the center. So here's one way to think about it. If you're spinning a rock, imagine a rock tied to a rope and you're spinning it in circles above your head, right? That rock, what would happen if you cut the rope? Well, the rock would just fly off in a straight line, right? In order to keep that rock moving in a circle, you always have to have a force, in this case the tension in the rope, holding it in that circular path. And that tension force is always going towards the center. So in order to go in circular motion, you have to have a force holding it towards the center. In my example I just gave, it's the rope. In the case of the moon orbiting the Earth, it's the force of gravity, is that inward force holding it in the circle. Okay, I'm going to do a video tomorrow going a little deeper into circular motion. But again, the big takeaway is that you are accelerating if you're in circular motion, and it's towards the center of the circle. Okay, we'll see you tomorrow. Thanks for watching.